Okay, guys, so as we go through the test together, please feel free to ask questions, whatever. Okay, if it's something you don't understand, I need to know that you don't understand. Just go ahead and ask me. Okay, it's not that many of us in here, so just unmute yourself and ask questions, big or small. Doesn't matter how small you think it might be. Please just ask your questions. Okay. All right, so let's look at this. It says, um, the Smith family purchased a home in 1950. Okay, so that's when they purchased the home, and that was for 25,000. Okay, the value of the home increased. Okay, approximately this much percent, 3.5% per year. So we know this is exponential growth. How do we know it's exponential growth? Because it's increasing by percent. Which function could be the model or could be used to model the approximate value of the home after t years? Okay, so if we use exponential growth, that's going to be y is equal to c parentheses 1 plus r to the t or x power. Are you good with that? Yes, no, maybe. Y'all okay? You good? I think I see Eleanor shaking your head. Are you good, babe? Y'all good? Okay. All right. Y'all gonna have to say something because I'm going crazy over here. All right. What's gonna be my C? What's my starting amount? Very good. 25,000. Excellent job. 1 plus, what's my R gonna be? Stop this over a little bit. Sorry. It's 3.5%, but I have to change the 3.5% to a decimal before I can plug it in. So in order to change that to a decimal, I move it 2 places to the left. So that's going to be 0.035. Questions about that? And then I'm going to raise it to the x power or t. Doesn't matter, x or t. Any questions about that? Okay, I'm going to combine like terms. I can combine this together. And so that's going to give me y is equal to 25,000, then 1 and 35 thousandths to the t power. This is the formula here. So which one of those is going to be the correct answer? Is it A, B, C, or D? C is going to be the correct answer. Okay. Number 2, the population of bacteria. Any questions about number 1? Number 2, the population of bacteria after X hours is modeled by the expression. This is the expression right here, and I'm going to rewrite it. It's 1,000, and in parentheses, you have 75 hundredths to the x power. This is an exponential function because it's raised to the x power, okay? The only thing that's missing is they didn't put y is equal to, and you can do that. What is the rate of decay? Okay, so we're using we're finding the percent that it decreased by. So to find the percent that it decreased by, you use B is equal to 1 minus R. This is how you find the percent that it decreases by. What am I going to put in the place of B? What's B in this problem? Okay, we're going to put 0.75 in the place of B. And now we're going to solve for R. Okay. In order to solve for R, get R by itself, I'm going to subtract 1 on both sides. And when I subtract 1 on both sides, what is this going to give me here? Negative 0.25. Okay, this is gone, and I'm left with negative R. Now to get R by itself, I'm going to divide both sides by -1 because I got to get rid of the negative. And this is going to be a positive 0.25 is equal to R. How do I change this decimal to a percent? Because we're looking for the percentage. We're going to move it 2 places to the right. So our answer here is A. Any questions about that? Did y'all get this one right or wrong? Okay, so let's do the next one, number 3. It says, the expression, we got 500, parentheses, 2 raised to the x power. This is an exponential function because it's raised to the x power. All the thing that's missing is the y is equal to. It says, can determine the size of the population that grows over a period of time. What does the 500 represent? What does the 500 represent in this problem? Does it represent the final size of the population, the initial size of the population, the amount of time necessary to double, or the rate at which the population is growing? It's the initial. This is the starting amount. It's the initial size of the population. So that's B. Okay. It says Sydney invested $2,800. The function v of t, or we can say y, is equal to 2,800 parentheses 1 point, we got 0.25 to the t power, models the value of Sydney's investment after y months. Okay, so this is we're dealing with months now. That's the time that we're dealing with. It says the function, this is another function, and it says 10t models the amount of money that Sydney has saved in her safe at her home after t months. Which function, c of t, models the combined value? So we're combining. All we're doing is adding these two functions together. Okay, so we're going to add them together. So we got v of t or y is equal to this 2,800 to the t power, and we're going to add to it the plus 10t. So let's just add plus 10t. We can't combine any of these terms together, so this is the combined amount here. Okay, and so that's going to be D. All we're doing is just adding them together. Any questions about that? Okay. All right. A club began with 3 members. Each month, each member brought 1 new member. Okay. It says which function can be used to determine the number of members X month after the club began. So think about it. The starting number is going to be 3. That's the starting number. Okay. So you start off with 3 people. All right. And those 3 people each brought a person. So how much is it total? You got the 3 plus you got 3 other people, right? Because each one of these people brought a person. So how many is that so far? Hello. Let me put it like this. Starting number is 3. So what's happening every single time? Each member is going to bring 1 new member. So if we start off with 3 people, I'll just draw sticks. And then each of those people bring 3 people. How many is that? Yeah, I mean, each of those people bring 1 person. How many people is that, y'all? Yeah, 6. And then each of these people bring one person. How many is that? 12. And then each of these people bring one person. How many people is that? Hello? 24. So what's happening every single time? How is it going up, Bob? You know it's increasing, but how is it increasing? I was going to draw it, but it just made sense to just put it in the table. Very good. Multiplying by 2. Okay. Nobody can hear your voices in the video, so you don't have to be afraid. Okay. So you're multiplying by 2. So this is it linear or exponential? Is it linear or exponential? This on there. Linear is when it forms a straight line, when the equation graphs a straight line and it goes up by a constant rate of change. You use y equals mx plus b. That's linear. Okay? And it grows by adding or subtracting to get to the next number. It's an arithmetic sequence. Exponential, on the other hand, exponential grows by a percent or it grows by a common ratio. So it's either going to curve upward or curve downward. Okay? And this is I want to say this is an arithmetic sequence. It's a geometric sequence. You add or subtract to get to the next number here. You multiply or divide to get to the next number here. So this is an exponential function, okay? You're going to use the standard form a times b to the x power. Okay, so here you add or subtract to get the next number. And here you multiply to get the next number. Okay? So our a is our starting amount, which is going to be 3. A is 3. And our b is the common ratio, the number that's being multiplied to get to the next number. So what are we multiplying to get to the next number here? We're multiplying by 2. So our common ratio is 2. So then the equation is going to be y is equal to a, which is 3, times 2 to the x power. Okay? So that's going to be D. And another thing that helps, this is an exponential functions quiz. So more than likely it's going to be exponential functions. Okay? This is dealing with exponential functions. Any questions about that? Pause real quickly. All right, number 6. Let's look at this one, okay? It says the graph below shows the value of Matt's car over 10 years. So let's look at this chart over 10 years. You see how it's curving? This is an exponential function, but it's exponential decay. This is exponential decay. How do I know it's decay? Because it's curving down. It's curving down. It's not a straight line. It's not linear. Linear is a straight line. Exponential is a curved line. Any questions about that? Okay, so let's look at this. It says, what is the domain? Domain is talking about the x values. So we need to focus on number of years. We need to focus on number of years. So it says, the domain of the function that best represents the values of the car with respect to the number of years. All right, so we're only looking at a 10-year period. So what are our x values? It's all integers. It's not going to be all integers because all integers would include negative numbers as well. We're only going from 0 to 10. So that's why it's going to be it's going to be all integers from 0 to 10. Not real numbers from 0 to 10, but just all integers from 0 to 10. Any questions about that? Okay. All right. And actually, because we could do 0.5 years. Yeah, we could do 0.5 years. So we could go with all real numbers from 0 to 10 since it does specify all real numbers. Because when you think about it, we can do 0.5 years, we can do 0.75 years, not quite a whole year, but almost, a year. We can do 2.5. So let's go with this one. This is a better answer, actually. And it's not going to be 25,000 years. That doesn't even make sense. So these two don't even make sense at all. It was really between these two. But come to think about it, you can have a decimal as a year. So we're going to go with all real numbers from 0 to 10. Any questions about number 6? Okay. Number 7, which graph best describes the initial population of 30 cows that is doubling every year? Okay, doubling every year. All right, so in other words, this is what this looks like. You start off with 30, so your A is going to be 30. I know it's an exponential function because it's doubling every 5 years. Since it doubles, okay, it's growing by multiplying every 5 years. It's something different. So look, this is what it would be. Let's do it just like this. We have our X and our Y. Our X represents the years. Might be easier for us to see it in a table. And this is the population of cows. Okay. So our starting year is going to be 30. And then every 5 years that doubles. So 5 years is going to be, when it doubles, what does that give us? That gives us 60. Okay. And then we got another 5 years is 10. What does that give us? Doubles. What's that going to give us? How many cows? 120. Okay. And then another 5 years is 15. What does that give us? 240. Okay. So we're looking for a graph that kind of can illustrate that. Okay. So let's look at our graph. We already know it's an exponential function because it's doubling. It has a common ratio. It grows by multiplying. Doubling means multiply by 2. So it's not going to be a straight line. Any questions about why it's not going to be linear? Because it's exponential. So you can mark this one out. Are we okay with that? Okay. All right. So then let's look at this one over time. Okay. Every five or so years. So we got 30 right here for this first year, which is good. And then we got, this is the 5th year. The 5th year, we put in 60. Look at that. That's 60 right there. That's good, right? That's correct. It's accurate. And then we put 10 years, and we went up to 120. So 120, what's it going up by? This is going up by 10s, 10, 20. So 120 is going to be up here. This is 100. 120 would be right in here. You see that? That looks like it's the right answer, doesn't it? So this is a possible answer. Any questions why this is a possible answer? Okay. So let's look at C. All right, another straight line. So no, this is linear again. And remember, it's an exponential function. So this is not the correct answer. Now let's look at D. Okay. D, again, it doesn't start at 0. It started at 30 up here. So this is not the correct answer either. So our answer is going to be B here. Any questions about how we got B as our answer? Okay, so pause real quick. Number 8, it says, suppose a certain type of bacteria doubles once every 30 minutes. During a 30-minute period, approximately 1/10 of the total bacteria die. Which graph best describes the potential number of bacteria? So we're talking about a certain bacteria now, and it's doubling. Okay, that means you're multiplying by 2. So again, it's an exponential function. So already you know to get rid of linear functions. Let me see if there are any that are linear, that are straight lines. Okay, most of these curve. So they gave you curved lines this time. All right, so there's hardly none you can eliminate. So you're going to be doubling once every 30 minutes. So every 30 minutes is going to double. Okay. During each 30-minute period, approximately 1/10 of the bacteria will die. Okay, so about 1/10 is going to die. So it doubles, but then every 30 minutes, 1/10 of it actually dies. So let's look and see what that would be. Okay, X and Y. All right. So if we start off, let's see, does it say what we start? How much it starts off with? Let's look at the answer choices. All of them start off with 10, it looks like. Yep, so they did give you that in the graphs. They told you that in the graphs they all start with 10. So let's start with 10. Okay. So it doubles every 30 minutes. So we got, if this is minutes, every 30-minute period. So is it 1? What are we going up by? Minutes. Let's look at the x-axis to see how much they're going up by. They're going up by hours. It's in hours. So we gotta use 0.5. All right, that was super important. This is hours here. Okay, and this is the bacteria. And see how I had to go back and look at the table to basically get my information. Because sometimes it's not always in words. So sometimes you do have to preview and look at the tables to see what information was given. Are y'all okay so far? Let me check the temperature, Paul. Okay, so now we're going to double every 30 minutes. So that's 0.5. So if I double every 30 minutes, then what's it going to be? What's the next one going to be? I need my calc because I got to take some away too. Use my calculator. So let's double it. Well, clear this out. So I'm going to double this means I multiply times 2. But I ain't really need a calculator to do that, but I just want to show you it's 20. And then it says approximately 1/10 of the bacteria. So we're going to multiply this by 1/10. So in parentheses, 1 divided by 10, about 1/10 of it, okay, will die. So this is 2. So I'm going to subtract 2. So when I subtract 2 from 20, because 1/10 of it dies, that's going to give me what? 20 minus 2, which is the 18. Okay, do you see that right there, what I did? Yes, no, maybe? Okay, said yes. All right, so I'm going to do, again, I'm going to double this. I say 18 times 2, okay? That's equal to 36, all right? And then I'm going to times it by the 1/10. Okay, I'm going to press enter, and then I'm losing 3.6, roughly, okay? So I'm going to say 36 minus 3.6. And it says approximately, so maybe about 4. So I'm losing maybe about 4. Okay, either way, that's about 32. Do you see that? So in an hour, it's about 32. So keep in mind that these numbers aren't exact. we're rounding. So this is about 32. Okay. And so in an hour and 30 minutes, this is 1.5. I'm going to do the same thing again. I'm going to double. So I got 32 and double times 2. That gives me 64. And I'm going to multiply that times the, parentheses, 1/10. Okay. And this, I'm going to subtract 6.4 from it. So I have 60 because that's how many bacteria is going to die. 64 minus 6.4. So that gives me 57.6. So it's about 58. Okay. All right. So now let's look to see which table is the closest to what we've got there. Okay. All right. So we started with 10, obviously. And then we went from 10, the halfway mark, 30 minutes, to about almost 20, 18 or somewhere in there. So we said almost 20. And then we went from there to about 32, but that's at 40. So this is really not a good answer here. All right, so let's look at this. This one is going 10. I'm looking at the table and looking at these values, okay? Going from 10, and then the halfway mark, which was 18 somewhere, and then at 1 hour is 32. So this is not a good answer. See, that's not a good hour. That's not a good answer because it's going up by 30-minute increments, and this is really going up by an hour. So that's not a good answer. All right, so now let's look at this one. And again, I'm looking at this table that I created. So I got 0 and 10. Then I got 0.5 and 18. That's good. Then I got 1 hour and 32. That looks pretty decent right there. And then I got 1.5 and 58. This is a great answer. Any questions about how I got C as an answer? Are y'all all right? Pause for the cause. Okay, and then when I look at this, look, that's not the answer at all. That doesn't correspond with the points that we created. All right, so let's put this up. Okay, let's look at number 9. A sequence, this is when we talked about sequences, is defined by, and look at this, it says the first term, a sub 1, is the first term, and the first term is 10. I hate when my phone does that. It's ridiculous. And the first term is 10. So that first number is actually 10. So if I was doing a table, I have my X values, which is the number of the terms in the list, and my output values. My first number would be 10, not my 0 number, but my first number would be 10. Now, what is it asking? What is it saying that I'm doing? Let's look at this. It says a sub n, and then it has 3 here, and then it has a sub n minus the 1. All right. So really what they're doing is multiplying by 3 because it says 3 times whatever the term is. So we're multiplying by 3 here to get whatever the fourth term is. Okay. So we got times 3 here. What's going to be my next number? All right. So here, I'm going to say this again because I pressed pause and didn't unpause it. This is 3 times, this is 3 times the a sub n minus 1. So basically, we're multiplying by 3 to get to the next number. Okay? We're multiplying by 3 to get to the next number. So you start with 10. It told you to start with 10 as your first number because it says a sub 1. It didn't say a sub 0. Then x would be 0, but it says a sub 1. So that's my first number. And then they're telling me to multiply times 3. So I say 10 times 3 to get this number. And then I say 30 times 3 to get the next number. Then it says 90 times 3 to get the next number. And this is the fourth number in the list. Okay. All right. Number 10. Number 10 says here is what is the simplified form of the expression? This is to the negative. You got to go back and look at your laws of exponents. This is raised to the negative 1 power. Anytime you raise anything to the negative 1 power or you write it as a fraction. So I'm going to change all of this into a fraction. I'm just going to say 1 over, and I'm going to bring all of this down to the bottom. Or I could just multiply this 1 or distribute if you don't want to look at a complex fraction. You can distribute this negative 1 to all of the numbers that are in the parentheses. So I'll do that because you probably won't like to look at a complex fraction. That'll probably be more work for you anyway. Okay? So I'll do that. All right, so let's do what's in the parentheses first. Let's simplify this to see if we can make it a little bit smaller. And we can. We got 3 divided by 6, and that's going to give me 1 what? 1 over what? Anybody know? Zoom in a little bit. I'll rewrite that. This is 3x to the 5th power. Wait a minute. Is that x to the 5th? Hold on. All right, so we got, this is 3 instead of 5. And this is y to the negative 4th power divided by 6x to the negative 2 y to the 6. Okay, I had to rewrite that because that's hard to see. So let's do what's in the parentheses. Let's simplify this, okay? When you divide, reduce this fraction first. So when I reduce this, what fraction is that going to be? 1 over what? 1 over 2, okay? And then when I do this, I subtract. So this is going to be x. Remember, when you divide exponents with like bases, you subtract the exponents. So that's 3 minus a negative 2. And then here, you got your y's. So that's y. Write this first. Whatever's on top goes first. 4 minus 6. Okay? We're doing all of this in the parentheses first. Okay? And then we'll deal with this last. So now this is going to be, and I'll write it over here, 1/2. Okay? And then here, minus a negative is plus a positive. So that's going to be x to the 5th power. Okay? And then this is going to be minus a negative. So that's going to be y to the negative 10th power. Okay? Are you good with that? Are y'all okay? Okay. All right, so now let's go ahead and multiply this negative 1. I could go ahead and move it, but that's okay. I'm going to multiply this negative 1 times all of the numbers that are in all of the exponents that are in the parentheses. So this is going to give me, when I do that, negative 1 times the positive 1 exponent that's automatically here is going to make this 1 to the negative 1 power. Okay. Here on the bottom, this is going to make this 2 to the negative 1 power. Here, this is going to make this 5 to the negative 5th power. And here, this is going to make this positive 10. Okay, so I'll deal with that. So now, to make it a positive, all I do is just move it to the bottom. If it's on the top, move it to the top if it's on the bottom. So my final answer here, to make this a positive, move it to the bottom. So now it's a positive 1. To make this a positive, move it to the top. Okay? To make this a positive exponent, move it down to the bottom. And this is already positive, so keep it moving. Okay. And so that number had to be something else. It had to be another number. Yeah. Had to be, because let's see, I don't see that. 2y to the 10th. Oh no, it is right here. So y'all write it is 3. It's 2y to the 10th, x to the 5th power. So it is D. Okay. I'm glad y'all got good eyes. I could not see that little number there. All right, any questions about that? Okay.